So MPLS, multi-protocol label switching. When you just enable MPLS, the labels are generated and the labels are assigned to every routes that are seen in the Ceph table. So this label will be inserted before sending the packet to the next hop. But the label that we insert will be the label given by the next hop. So when we give a label the packet, whose label we insert in the packet, it's the label of the receiver. So when I put the label given by my neighbor and send the packet to the neighbor understands exactly what it means because the neighbor only gave the label and we are using the label. So in the packet, it is added after layer 2 and before layer 3. Each router will only process the layer 2.5 header, which is only 32-bit size, in which 20-bit or label and 3-bit or TOS bits, T bits or COS bit, which is also called as experimental bit. And then you got 1 bit, which is called as bottom of a stack, and then 8 bits for the time to live. So is there anyone here who don't know these things, or do you have any question? I'm in an impression that I have already delivered these things. So there is no question, that's what you mean. Okay, what about others?
I'm okay, sir. Yeah, I'm okay.
Okay. So this part is over. LDP is also involved in distributing the label, those things we discussed. Can anyone tell me the port number LDP uses? MPLS, when you enable, yep, 646. Excellent. That's nice. Do you have any other protocol like LDP? Do we have any other protocol like LDP? Yep. What's the port number?
771.
Correct. That's great. So I think we have covered these things very well. We need to move to the next one. I was talking about MPLS layer 3 VPN. For MPLS layer 3 VPN, what is necessary? First thing, you need to have reachability between those provider edge router between which you want to form label. Right, let's say you got a topology like this and you want to have a tunnel between PE1 and PE2 because you got customers connected. Let us now first focus on one customer, not customers. So you got a customer called Green connected to different P's. Now the route advertised by router Green 1 should reflect in the routing table of router Green 2, for which you are willing to have a tunnel instead of advertising every network to all the routers inside the provider network. Instead of advertising all the customers route to every router, provider wants to have a tunnel between these two so that when a customer advertises route, comes to the routing table, and the routing table will be a dedicated routing table for the customer. We create a customer's routing table by using a concept called VRF, virtual routing and forwarding. Likewise, we have another VRF here, and this interface is a member of VRF. So anything that comes as an advertisement in this link, this interface, and to this port will be only reflecting on this VRF routing table, not on the global routing table. There is also a global routing table which has got these internal interfaces as a member. Yeah. So you got a global routing table as an internal interface as a member. And the external interface, the customer facing interface, is a member of a different routing table called VRF. Same way here also you got a global routing table and a VRF routing table. So the route is now in this green routing table and it is placed into the tunnel and goes straight to the other end of the tunnel. And again, it will not be in the global routing table, it will reflect only in this customer's green routing table. And from there, it goes to the remote customer site. But to achieve this, there are a lot of things to be done. What? Number one, you need to form an IBGP between provider edge 1 and provider edge 2. In order to form IBGP between these two, you need to have a reachability. To provide reachability, you should be running a link state routing protocol, let's say OSPF. So internally, you got OSPF running between the provider edge router. Right? So using this reachability OSPF provider reachability, you got IBGP. And once the IBGP session is there, it is good to now activate the VPN v4. We activate VPN v4. VPN v4. VPN version 4 between these PEs. That is also with the help of MPLS. Now the VPN v4 is ready, and also MPLS is running on every router here. You must run MPLS. Only then, over this VPN v4, a label will be advertised. On behalf of all the customers network, there will be a label advertised, and the label will be reflecting here. fine. So you must run MPLS. So for every customer's route, there will be a label given by PE2 so that PE1 can use the label and put it inside the tunnel. And again, the tunnel is built by using the physical network. So to move across the physical network, there will be another label. Focus very carefully for PE1 to go to PE2, which is the tunnel next stop. There is a label, we call it as service label. Now to go to the tunnel end, you need to go to multiple routers in the middle as hops. So for each hops, you will have a different label provided by those internal routers. Right. So there is a service label, there is a transport label. The internal hops is what transport. What is next? First thing OSPF, second thing MPLS, thirdly IBGP, fourth VPN v4. What is next? We need a separate routing table, I told you. So you create VRF. And then to identify the routing table, VRF name is not sufficient. Actually, when you create VRF, you will be giving a name like VRF green. Here, for the same customer, you don't need to give the same name. If you want to give different name, you can give different name. Or if you want to give same name also, it's okay. But what I'm coming to say is the VRF name doesn't need to match. So I'm going to give this side VRF some name, Pachai, PACHI. Actually, same customer, but I'm giving different name just to tell you that the name is locally significant. And also, in the VPN, when the route is going from this green, just to tell the VPN members that it's coming from green, we have another ID called route distinguisher, which is 64-bit size. So I can give a route distinguisher like 1:1, 32-bit colon 32-bit, 1:1. And you need to provide route distinguisher even here, route distinguisher. I'm giving 11:11. Nothing wrong in giving different router distinguisher on different PE. Next. What is the role of this route distinguisher? Just to tell that these routes are coming from this particular customer. That's all. This is not going to take decision to whom it needs to be sent. It is not for deciding to whom. It is just to tell from where it is coming. So if you go to any router, that has got VPN turn-line point and type show BGP VPN v4 unicast. All, enter. You will see that these routes are coming from, let's say, for example, 1.1.1.1. It will say this route is coming from 1:1. Then you understand it is coming from green system. And let's say this is 2.2.2.2. Route distinguisher will have 2.2.2.2, route distinguisher 11:11. From that, you will understand that this is coming from Pachai. Just to tell from where the routes are coming. You need route distinguisher. It distinguishes one customer's route from other. That's route distinguisher. Next. There is another feature. There is another not feature. In this feature of VRF, there is another entity called route target. This is very important. This determines to whom the updates will be delivered. See, there is an update coming from green. If you want it to be delivered to Pachai, you need to use the route target properly. For example, if I say route target 100:100 as export value 100:100. In this Pachai, I need to say route target import 100:100. So this is also 64-bit value. So this will be looking for, this Pachai will be looking for updates attached with 100:100. When it see any update attached with 100:100, it immediately grabs it. It immediately attracts it. It immediately downloads it. Likewise, on the Pachai, you export with the same number or different number, let's say different number 20:20 route target. Here, if I want the route available in the green, I need to say route target import 20:20. So that export matches here import. So this 2222 will be not appended with 20:20. When the provider edge 1 see 20:20 with some route advertisement, it immediately downloads it because here it is said import. It imports it. Yeah.
So can you just repeat one more time the route that export the name? Before you do that, can I ask one thing very quickly? Is route distinguisher associated to every VRF?
Every VRF should have a unique route distinguisher.
Right. So VRF is what maintains the separate routing table for the customer, and route distinguisher is the VRF is what enables that.
Can you please repeat?
So VRF is what keeps the customer's routing table separate on the router.
Yeah. On the router, VRF route distinguisher keeps the route separate, you can say, but more appropriate answer will be in the VPN to know from where the route updates are coming. from which customer the route updates are coming. Route distinguisher is there, but to whom need to be given is not based on the route distinguisher. It is based on the route target. So I could say I want to say that on the router, though it is going to use route distinguisher, on the router you can manage very well with the what the VRF name.
So even if you don't give the route distinguisher,
Uh,
you will still keep the route separate with the VRF.
yeah, that's right. But route target is not mandatory for VRF to come up, but route distinguisher is mandatory. Mm.
I see. Okay.
Route target, if you give, then the advertisement will be given to other PE. If you don't have route target, advertisements don't go. When we do the practical, it will be more clear. But still, if you have a question, you can ask if you're not clear.
And and what is this VPN V4?
That's the command to form a VPN, negotiate a VPN um, between the PE routers using BGP.
That,
Hmm. Yes.
then I'm just trying to understand what I'm. Just correct me, sir, if I'm wrong.
Hmm.
Let's say I have a server VRF, I have a user VRF
Hmm.
in my lab,
Mhm.
and the server VRF and user VRF, only VRF. I'm not getting into the route RT and RT. So in the VRF, sir, we have separate routing table.
Mhm.
That is part of the server VRF, that's part of the user VRF. Now I want to do the communication between server and user.
Hmm.
Let's say user VRF might need to talk to server VRF. So in that situation, my RT and RT will I can play with that. If we import or export route,
Hmm.
then only it will be able to communicate.
Yep.
That's means can we say it's kind of route linking?
Mhm. Okay. Yeah. It's a tag value that needs to match. That's right.
Okay. But this RT and RT it can be anything. Means I mean to say, let's say in my port I have a RT value one colon one.
Hmm.
The same VRF other switch might be I will have a two colon two.
No
Will it
problem.
be?
No problem. Route distinguisher can be different for the same customer. Nothing wrong. It's only the route target that needs to match.
Okay.
Any other
If
question?
user subnets and if user subnet wants to communicate with the server, then I need to get into the server VRF and then I need to import route target of user VRF.
See. You have gone beyond the portion that I have covered. Okay, you have gone very beyond. We are simply talking about one VRF, one VPN. You brought two VRF that I appreciate, just to tell that how they are separate in the VPN. But now you are talking about interlinking between VRF. For everyone, this is not understandable. So wait some time. But you already have the answer also. What you said is correct. It's a route target that you are going to use to leak. Uh, Route target of what to say? You gave me two. Route target of server should be matching with the route target of the other one. That's all. It's going to work, but not everyone in sync. Okay. Um,
Because I'm trying to correlate the green and
mm.
so
I
I'm
didn't
not
have blue here. I don't have blue here, no. Mm. Anyway, so please understand first, focus on one VPN, bring it successfully, and ping between the sites. Then we can talk about multi VPNs and merging between multiple VPNs, the multiple customers. It's too early for us to discuss about merging two sites of different customers. It's okay. Now, let me repeat everyone again. See, you have OSPF, so the provider's routers in the provider network. Routers, the provider network also has got that three layer, okay? Access layer, distribution layer, and core layer. There should be reachability between those devices inside the service provider network. So you need a routing protocol. We got OSPF, and you got MPLS, so that you can have a VPN v4 or a layer 3 VPN, which is also called as layer 3 VPN. VPN v4 is nothing but layer 3, right? What is VPN v4? V4 is what? IPv4. What is IPv4? What is IP? Where is IP address? Layer 3. So VPN v4 is nothing but layer 3 VPN. Now, in order to have a VPN v4, first of all, you should have an IBGP between those two routers, which is going to be VPN v4 tunnel endpoints. Fine. After which, um, after you configure VPN v4, when the VPN v4 comes up, so you need to now configure VRF. VRF names for the same customer who is in different location can be different. Like I have here green and pachai. Yeah. So not only VRF name, even the route distinguisher can also be different for same customer. See, pachai is nothing but green only. In another local language called Tamil, green means pachai. Pachai means green. Only the spelling is different. So why I'm writing this, just to tell that name can be different for the same customer. Route distinguisher can also be different. That's why I said in the green 1:1 and in the pachai 11:11. What is next? After this, you need to decide whether I will be giving the routes of green to pachai. If you decide to give, then your export value should match on the import of pachai, and export on the pachai should match on the import of green. Only then the 2.2.2.2 will go to router G1, and 1.1.1.1 will go to router G2. Yeah. So this is it. So what is next is, after we provide the proper route targets, we need to assign this particular interface to that VRF, and then we need to form an eBGP so that the route this will be advertised via BGP, and it goes through the tunnel to the other. Likewise here also you do eBGP. That's all. This will bring up the layer 3 VPN. See, I'm going to quickly do this for you. VRF. If you see, I have given a spelling called blue. Blue. And here, show IPVRF. Blue. And also, if you notice, the route distinguisher here is 12:12, whereas here it is 112, 112. Right? So this is to prove that the route distinguishers can be different, name can be different. Next, show IPVRF detail. In the green, where is green? This is yellow. I don't want yellow. In the green, if you see, sorry, in the blue, if you see, I have route target 2:2. I also have 1:1. Let me go and see the other side. Show IPVRF blue detail. And now I want to see only here. If you see, the route target of green, blue is 1:1 is exported. Good thing is you are also importing 1:1, and 2:2 is imported here, and 2:2 is exported here. I want to. It's okay. So that's it. Right on the yellow, if you see the route target, both import and export is same. As a result, if you go to router 6, I'll be able to ping. Show IP route. There's nothing in this router. Need to be configured. Show IP interface brief. No. G3/0. No, nothing. So let's do it. Interface G3/0. No shut. IP address is 26.26.26.6.255. Interface loopback 0. IP address is 6.26.6.6. And then I'll run BGP router, BGP 20, neighbor 26.26.26.2, remote AS is 100, network is 6.6.6.6, mask is 25525. So the customer is advertising this network. Now, show IP BGP. Look at this. I have learned this 5555 from the remote site, Autonomous System 10. And if I ping now, fighter 5, the source of 6.6.6.6, the ping happens. And if I trace the route now, fighter 5, the source of 6.6.6.6, you can see two labels. One is the VPN label 23. 23 is a VPN label inserted on router 2 and popped off on router 1. 18 and 17 are the label in the middle. From router 2, it goes with 18 to reach router 4. You know why? Router 4's label to reach 11111 is 18. Let me show you. I don't know. See, I just learned from this output, okay? If I go to router 4, I'm expecting 1.1.1.1 to have label 18. Likewise, router 3's label for 1.1.1.1 will be 17. Let's go to router 4 first. 4, show IP, not IP, show MPLS forwarding table for 1.1.1.1. You see, the local label is 18. And the label given by the following router, router 3, is 17. This is 17, this is 18. Okay, so what we have discussed is matching. So in the next class, what we are going to do is we are going to build this topology from zero level. build this topology from zero level. All right. Now what I'll do is I'll just show you the routing tables of each customer. For every customer, there will be a separate routing table. On router 2, if you go and check show IP route, you will see only the global routing table. If you want to see the customer's routing table, then you need to say show IP route VRF star. So first it will show you the global routing table, followed by blue, and yellow. I think yellow there is a problem. There is no route. Maybe these routers are off. That's why it is not having. Okay, so I think you might have got some knowledge on what is layer 3 VPN. Now, if I take you to router 4, you will not see any routes of customer 5555 and 6666. Let me show you router 4 because it is only through tunnel. R1 knows the customer route, R2 knows the customer route. R4 show IP route, nothing. Nothing related to 6.6.6.6 and 5.5.5.5. Show IP route VRF star, nothing will be there, only the global routing table. There is no VRF. Show IP BGP, there is no BGP also in this. Show IP VRF, there is no VRF. So we are forming only tunnel between R1 and R2. BGP is running only between R1 and R2. Anyone has got any question?
The threshold still showed some hops in the middle, right? Or was it just the endpoint of the tunnel?
No, it will go till the last customer, friend. It goes till the customer's router. You see, the customer's router is 15.15.15.5. This and G3/0 of router 5. I'm tracing.
What I was trying to say, no, what I was trying to say is like the tunnel is from R1 to R2.
Yeah, so that's why you see, from here to here, label. Router 2 is inserting the label given by router 4 and sending to router 4. Router 4 receives like this. And router 1 has popped the label. Router 3 has popped the upper label, the transfer label, and only the service label comes up to router 1, and router 1 pops it off and sends to router 5 because we don't have MPLS on router 5. Why there is no label here? Because for R6, R2 is the next hop. There is no label between R5 and R2 and R6. Between R2 and R6, there is no label. Any other question? Okay, so